Hi, I'm Anton. I would like to give you an introduction to Promise. So this is what I've built for the Chainlink Fall 2022 Hackathon. Everything I'll show you is available on the demo at usepromise.xyz, and you can find some more detailed explanation in the documentation, as well as some guides to use the app at docs.usepromise.xyz. So I leave the what is promise and why to the documentation. What I want to show you here is how you can use the app. So the first thing we'll explore is a promise creation. You can choose a name and add as much participants as you want using a name and an address. It is not required to give a Twitter username, but highly recommended since it is actually what ties the promise to your reputation. You can then add any files to the promise, like a roadmap, a white paper, some sketches, anything. It will be sent to IPFS, and you can choose whether you want it to be sent to Arweave as well. Sending to IPFS is done through the Web3 storage client, which also makes sure to find some deals with Filecoin miners so that the content is secured. If you do check the Arweave checkbox, it will bundle all the files into a zip and send it to Arweave using Bundler, which, among others, lets you pay in Matic here. So everything you can do on Promise, you can also do it from the contracts. The only catch is that only if you use the application, it can guarantee that the content was indeed sent to IPFS and Arweave, and therefore display that guarantee on the Promise. What happens is that it takes your address, the IPFS CID and the Arweave ID, encrypts it along with a secret key, and puts that encrypted proof along with the other parameters. Once the promise is created, our external adapter will take that encrypted string, decrypt it with the same secret key and say like, okay, I got the same address, the same IPFS CID and Arweave ID. I can attest that this content was indeed sent to IPFS and Arweave. So if created straight from the contract, we can't know for sure that the IPFS and Arweave hashes are even valid. So here is how it will be displayed, and it will show the Arweave ID and let you download the zip on a click. So here we got exactly what we saw: the name, the IPFS CID, the parties, the IPFS directory, and the contract address. Since each time you create a promise, it creates a new contract that will hold its data and states. What you see here, that node icon, is kind of a reliability indicator. It shows how many peers are pinning the content and how many deals it could make with miners on Filecoin, and will turn into green only if there are at least 3 peers or a Filecoin deal that is still active for at least a year. There are the other parameters, the approval status and Twitter verification, which we will see right now. Back to the dashboard, you can see the promises you've created and the ones you've been added to. Anyone involved in the promise can add participants. Once it's done, it revokes all approvals, because when you approve a promise, you're both saying, okay, this is my Ethereum address. I'm indeed involved in this promise and I recognize that IPFS content, but also you agree together with the other participants. And once everyone has approved, the promise can then be locked, and at this point you can't add any participant anymore. It's kind of a guarantee that a promise won't change even a bit anymore. The only thing you can still do is verify a Twitter account, which you won't be able to undo. That's kind of the whole purpose of Promise. Here you can explore the Twitter accounts verified for an Ethereum address. You can verify as much as you want. It is worth noting that it is done in a non-intrusive way, meaning that you just need to tweet some string including your address, make a request to the Chainlink node, and the external adapter will read your latest tweets and attempt to find that signature. If it does, you're verified. And you can even do all that from the contract by just giving your username and making a request. You can also see the app as a way to know in which projects a user might be involved with by just searching for their address or Twitter handle. That's kind of the same with the verified Twitter accounts page, on which you can just search for a username or an address and see all their associated addresses or accounts. So yeah, that's all, and of course there's that cool WebGL particle effect. I hope you will enjoy using it, and again, there is everything in the documentation if you have any doubt. So thanks for staying with me, and bye!